In the previous video, I have generated the project petstore-proxy in the Lite4j repository. In this video, I'm going to walk through the project. If we go to Lite example 4j Lambda petstore-proxy, you can see we have events folder. We have 4 different events for testing with local Lambda functions using Docker container. So for each Lambda function, we have a separate repository project. So we have pom.xml and all the Java code generated, as well as the test cases generated. So within the generated Java code, we have app.java. This file is not supposed to be updated. For developers, you only need to update business handler.java. And you can see we generate business handler using the specification, the OpenAPI specification, and this line is generated from the example in the spec. So we return some meaningful example data after the code generation. And this file is supposed to be updated with your own business logic for the Lambda function implementation. In this resource folder, we have a YAML file. You can have local configuration for different stage. And we have logback.xml for the login configuration. Every endpoint, you have a Lambda function, corresponding Lambda function. And we do generate a proxy configuration for the Lite proxy as well. Within the proxy configuration, we generate most configuration files. And the most important config file is Lambda Invoker. This file will specify which region the proxy is deployed to. And we set the log type as tail so that the Lambda function log can be tailed to the proxy log. So we don't need to collect Lambda function log specifically. All the Lambda function invoked by the proxy will have the log tailed to the proxy log, so that we can send the same log to the Splunk or ERK for centralized logging aggregation. The most important thing we generate actually is this. For every API endpoint, this is REST API, we map a Lambda function name so that when this endpoint is invoked in the Lite proxy, subsequently we're going to invoke pets-get function. The function actually is defined here. This is the Lambda function we're going to invoke for this endpoint. There's 4 different endpoints, and there are 4 different Lambda functions here. The other file we need to take a look is the handler.yaml. This handler.yaml defines the request response chain for the middleware handler. So those are the middleware handler we're going to wire into this Lite proxy. And the difference then the proxy usage for the backend API sidecar is we have a special handler defined here. It's called Lambda function invoke handler. And we have an alias defined as a Lambda. And you can see we put this as the last handler in the default chain definition. So that meaning after exception, matrix, traceability, correlation, body, parser, audit handler, specification, security, validation, after all these cross-cutting concerns addressed, then we invoke the Lambda function. So you can see we have 4 different endpoints defined here, and all of them using the default chain, so that when the endpoint address all the cross-cutting concerns in the Lite proxy, we invoke the Lambda function. We also have health check, server info, log get different logging level, as well as a post. We update the logging level on the fly from our controller. The spec also can be displayed using the spec UI. So all of them is generated on the Lite proxy. The other file we need to take a look is the OpenAPI YAML. This is exactly the same OpenAPI YAML we use to generate the code, and we have this as part of the delivery in the Lite proxy, so that the Lite proxy can validate the scope in the generate token per endpoint. You can see we have read paths as a scope defined here for this particular endpoint. At the same time, we have a schema validation or OpenAPI specification validation in the light proxy. We use the specification to validate the request, so that only the valid request will go to the Lambda function. Yeah, that's pretty much like the most important configuration file for the proxy. This is the file we use to build the proxy. If you look at here, we are basically creating the Docker image using this local light proxy target light proxy jar. And in the once we have this new version, the light proxy released, we're gonna switch to get this light proxy jar from release directory. For example, release from 2.0.0.20 from GitHub. So temporarily, we're just using a local build light proxy jar for this tutorial. We also have Docker file for the proxy. And you can see the Docker file from the proxy. We just copied the proxy jar as a server.jar and copy the proxy folder, which contains configuration to the /config. And we start this jar file using the java-jar with some configuration externalized, as well as externalized logback.xml. We also generate this public proxy YAML. This basically give us a CloudFormation config file, YAML file, for the proxy deployment. You can see we have all the parameters defined here. This is the important thing is the image URL. Where is the proxy image coming from? And the port number, as well as the access key ID and secret access key. So those two are very important to invoke Lambda function. If you don't have this, you cannot invoke Lambda function. You need to create an access key and the secret from the console with a particular role. You can invoke Lambda function. And when you create this stack, deploy the proxy, you need to specify the key ID as well as the secret access key. And here we define the resource task definition. We have the service name is in from the parameter and all the service definition here. And we have service defined here. And the target group. So we have another public VPC YAML created. So in the VPC, we have a default target group. Now we specify this target group for the deployment. We also have load balancer rule, so that we can load balance between multiple instances of light proxy. If you take a look at public VPC, this is how we create two EC2 instances to deploy the light proxy Docker image. We are using T2 micro as a default, and for the default, we are using 2 instances of EC2, and maximum 4 when we do the redeployment. So when we shut down the old Docker container, we don't shut down them immediately. We deploy the new ones, then we shut down the old ones, so that we can have service continue working. Yeah, this is the VPC, and we have 2 public subnets. Subnet 1, Subnet 2, and we have an internet gateway so that we can access our proxy from internet. We also have a load balancer config so that you can access the 2 different proxy instances from the internet gateway. The output, we need to pay more attention on this output, which is the external URL. So this external URL will be the URL we can access our light proxy, subsequently access the Lambda functions. Yeah, the Readme file contains all the information how you build and deploy Lambda functions, as well as how you deploy the VPC and the proxy. All the functions defined here, and this file is generated based on whatever the configuration you have. And you should read this file before you start any tutorial actions. The template YAML actually is defined for the Lambda function, so that you can deploy Lambda function with this template YAML. In this template, we have 4 different Lambda functions defined here as the resources. You can see the URL and the function name and the path and the method for the endpoint. Yeah, because we don't use AWS API Gateway, so there is no API Gateway resource defined here, but we are using light proxy to replace the API Gateway. So that's pretty much like all the files and the folders we in the generate project. In the next video, I'm gonna walk you through how to deploy the VPC and build the Docker image for the proxy. Thanks, bye.